We're looking at the discriminant of a quadratic equation here. So to start off with, let's write down the quadratic formula. The general quadratic equation is ax squared plus bx plus c equals to 0. The quadratic formula, which enables us to find the x values, i.e. the solutions when y is equal to 0, is x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Now when we solve this, we can get either two solutions to the quadratic or a single or no solutions. Now, if you remember, we said that when we solve a quadratic, we're looking at where the quadratic curve crosses the x-axis, i.e. when y is equal to 0. So if we were to draw it like that, it would cross the x-axis twice, giving us two solutions. Or you could have a quadratic which looks like this, in which case it doesn't cross the x-axis, no solutions. Or you could get a quadratic which simply just touches the x-axis, giving us just one solution. And how we can determine how many solutions it has is by looking at this thing here inside the square root, which is referred to as the discriminant of the quadratic equation. Now it will always, the discriminant is always associated with a quadratic equation. So if we have a quadratic equation, then we can determine its discriminant. It will enable us to find out whether it will have two solutions, one solutions, or no real roots, or no real solutions. So let's go and take a look at these examples here. So remember what we said, the discriminant is b squared minus 4ac. So I'll write that down here. Discriminant is equal to b squared minus 4ac. So here we want to determine the number of solutions for each of the quadratic equations below. So let's start by writing down what the discriminant is. So in this first example, b squared minus 4ac. Well, what is that? You can see b squared is 8 squared minus 4 times a is 1 times c, which is 3. So that gives us 64 minus 12, which is 52. And if we were to go and solve this using the quadratic formula, we would have, well, we can actually factorize this. So let's see what happens if we factorize this. We get, oh, sorry. So we've got b squared minus 4ac is equal to 52 here. Now, if we were to sketch this, when the discriminant is greater than 0, as we have here, this quadratic equation would have resulted in us having two solutions. Let's see what those solutions are. We can find them quite easily by finding the equation, the values of x. X is equal to minus b, which is 8, plus or minus square root of b squared minus 4ac, which we know is 52, we've calculated here, all over 2 lots of a. So this gives us minus 8 plus square root of 52, and all of that divided by 2. That gives us, first of all, I'll write it just down to two significant figures here, minus 0.39, or we get x is equal to minus 7.6. So what this suggests is that there are two solutions. What would this look like? Now, if we were to draw this, What does it look like? Well, let's take a little look at a sketch. There's two values, one here, one here. Look like a quadratic like that with two solutions as we found here. What about the second example? Well, let's take a look at, first of all, its discriminant, b squared minus 4ac. Write down the discriminant first. What is it in this case? Well, b squared is minus 8 all squared minus 4, lots of a, which is 1, times c, which is 16. And if we get that, the answer comes out to be 64 minus 64, which is equal to 0. So let's go and take a look at solving this to actually find out what it would look like if we were to sketch it. So x is equal to minus b plus or minus square root of the discriminant, b squared minus 4ac, which we've already worked out to be 0, all over 2. So this, as you can see here, because the plus or minus is of plus or minus of a 0, we've got 8 plus or minus 0, which actually doesn't have anything, it's just 8 over 2. So we only get one solution here, x is equal to 4. So if we were to sketch this, what would this look like? Let's take a look. It goes through x is equal to 4 and simply just touch it there at x equals to 4. So it only has one solution. So the third case is, let's find out what this is going to give us. B squared minus 4ac, and b is minus 3 in this case, minus 4, lots of a times c, which is equal to 9 minus 32, and that gives us minus 23. So the discriminant is actually negative. If we were to try and solve this, what would it look like? X is equal to minus b plus or minus square root of the discriminant, which we've worked out to be minus 23, all over 2 lots of a. And as we can see here, when we try and put this in the calculator, we get square root of a negative number. Now this square root of a negative number gives us an error on the calculator, indicating there are no real solutions. So there are no real roots. So no real roots, meaning it doesn't cross the x-axis. So if we were to sketch this, what would it look like? Well, if we were to sketch this, it would be something simply up here without any intersection with the x-axis. So what can we conclude from this? That when the discriminant b squared minus 4ac is greater than 0, what do we have? We have two real distinct solutions, distinct meaning they are both different. When b squared minus 4ac, the discriminant, is equal to 0, we have one root, or this root is actually a repeated root. So sometimes you will see repeated root or one root. The word root and solution are interchangeable here. They mean the same thing, roots and solutions. I'll write down the same thing here just so we're all clear. So we've got repeated solution. And here we have no real solutions. So this is the case for a single quadratic curve, the discriminant. Now we can get quadratics formed from many different scenarios. So let's take a look at some of these other scenarios here. So here we're looking at determining the number of points of intersection for these pairs of simultaneous equations. Now understand what we've got here. We've got a quadratic curve and a line. So if we have a quadratic curve and a line, and we're solving these equations, What we're actually solving, if you remember, solving simultaneous equations results in us finding the intersection of these two equations. One is a quadratic curve, the other is a line. So the line and the curve could intersect at 2 points, giving us potentially two solutions. Or it might be that it actually doesn't intersect, giving us no solutions, or it could just touch it, giving us just one solution. Now let's determine how we can find out how many intersections it will have. And the process is, first of all, you start by doing what you would normally do to solve simultaneous equations. Substitute one into the other. So I'll substitute equation number 2 into equation number 1. So I end up with 2x plus 8 is equal to 6x squared plus 3x minus 7. Let's get it into the form of ax squared plus bx plus c equal to 0. So this will, if I minus 2x and minus 8 from both sides, I will end up with 6x squared plus x minus 15 equals to 0. Let's go and take a look at how we would find the discriminant now that it's in the form of ax squared plus bx plus c. Remember to always get it into this form. Ax squared plus bx plus c is all equal to 0. So what is our discriminant for this quadratic? Since we've now formed a quadratic, we can treat it as a quadratic and determine how many solutions this quadratic will have. So the discriminant is 1 squared minus 4ac and this gives us 361. Now, since the discriminant is greater than 0, it indicates that this quadratic curve, I'm just going to draw a generic quadratic curve here, and this line will intersect at 2 points. Okay, so b squared minus 4c, therefore 2 intersections, 2 real solutions. And it would look like this, where there are 2 intersections. Let's take a look at the second example, how you'd approach that. Same way, we would start by solving, substitute equation 2 into equation 1. You're going to get 10x minus 9 equals to 4x squared minus 18x plus 40. This then becomes 4x squared minus 28x plus 49 equals to 0. And the discriminant here becomes minus 28 all squared minus 4 lots of a times c which is 784 minus 784, which is equal to 0. This tells us that the b squared minus 4ac, the discriminant, is equal to 0. Therefore, we have one intersection or a repeated solution, i.e. the same solution appearing twice. So what would this look like? It would be a quadratic curve, and the line would simply intersect it at 1 point, i.e. be tangential to the curve. Let's look at the third example. Again, start by substituting equation 2 into equation 1, the easy one into the harder one. We need to rearrange this a bit, so it will be y is equal to minus 7x minus 3. Substituting into equation 1 gets us minus 7x minus 3 is equal to 3x squared minus 2x plus 4. Make it equal to 0 to get it into the form of ax squared plus bx plus c equals to 0. Get 3x squared plus 5x plus 7 Let's work out what the discriminant is to determine the number of intersections here. So 5 squared minus 4 times 3 times 7. And this gets us minus 59. And since the discriminant is less than 0, we can say, therefore, no intersections or no real solutions. So what does this look like? Well, it would be a quadratic curve, and the line would simply miss it. It doesn't intersect it. So this is looking at a quadratic curve in a linear. Now, let's look at one more scenario here, which is looking at trying to determine the number of intersections between a circle and a line. So we've got the equation of a circle, the top ones in each of these cases, and the line. Start by doing the same thing. If we're trying to determine intersection, we would try and solve this simultaneously. So substitute equation 2 into equation 1. So we have x squared plus, instead of y, we write x plus 5 minus the 2 all squared equals 29. Tidy this up a bit, so you end up with x squared plus x plus 3 all squared equals 29. If we expand this, we get x squared plus 6x plus 9 equals to 29. Get it into the general form of a quadratic, ax squared plus bx plus c, we end up with 2x squared plus 6x minus 20 equals to 0.